Imagine descending into a pitch-black shaft, with only a candle for light, your pickaxe striking rock, in rhythm with your pounding heart. This was daily life for medieval miners, the ones who provided the metals that built kingdoms. Where did their story begin? With simple bell pits, and it evolved into more sophisticated operations, the kind that would impress even modern engineers. Today, we trace the journey of medieval metal from hidden veins in the earth to the weapons and tools that shaped history. Let's begin where it all started, finding the ore. So how did medieval prospectors actually find metal deposits without modern equipment? The search began with careful observation, surface indicators, and local knowledge passed down through generations. But here's the challenge. Most deposits were hidden deep underground, with absolutely no visible signs from the surface. What did they look for? Subtle geological clues that might whisper what lay beneath. They used water dowsing, holding forked sticks said to twitch over underground water that often accompanied mineral veins. They studied plant growth patterns, noticing some plants thrived in soil rich with metals. They spotted mineral stains on rocks and discoloration in soil, vital markers of possible ore. They even followed animal trails, watching where creatures grazed, since animals often sought out soils with the minerals they needed. And of course, they revisited ancient Roman mining sites, knowing the Romans had already chosen favorable ground. In the end, the process was a mix of practical observation and superstition. And the result? A high failure rate for most prospecting attempts. The key to knowing whether a hillside held valuable metal was systematic observation, those subtle geological signs, combined with inherited knowledge. It was a blend of early earth science and traditional belief. Every clue mattered. And success? It meant not just finding ore, but recognizing which sites held enough material to justify the immense effort of extraction. That careful searching, that interpretation of the landscape, marked the crucial first step. What was it actually like to work underground once they found a promising site? Medieval mining operations ranged widely, from simple surface pits to complex underground networks. Each carried its own challenges. Miners faced constant danger, collapsing tunnels without warning, floods rushing in to trap them below, toxic air that could silently overcome a worker. The deeper they went, the greater the risks became. For shallow deposits near the surface, workers used what were called bell pits. These were excavations that widened downward, like the shape of a bell, allowing miners to reach ore without tunneling far beneath the earth. But as operations sought deeper veins, they developed shaft mining techniques with timber supports to prevent collapses and primitive ventilation systems to circulate air. These systems were rudimentary at best, sometimes just a series of strategically placed fires to create airflow through connected shafts. The tools they used were basic but essential. Iron picks and hammers smashed rock and ore, while baskets hauled the material to the surface. Workers operated in near darkness, with only candlelight or small oil lamps to see by. The labor itself was brutal and physically demanding, often performed by forced workers and prisoners who had little choice in the matter. They worked long hours in cramped, unstable conditions, where injury or death was a daily possibility. This dangerous extraction process was just the beginning of the metal's journey. The raw ore they risked their lives to obtain now needed transformation through smelting and forging. What emerged from these mines was merely potential. Rock containing metal that required skilled hands and intense heat to become something useful. The mine was where physical labor met geological reality and where human endurance was tested against the Earth's resistance. So how did medieval workers transform that raw rock into usable metal? Smelting required reaching temperatures that would seem impossible without modern technology, and different metals needed completely different conditions. The process demanded precise control over heat, airflow, and chemical reactions that could make or break an entire operation. Bloomery furnaces were the standard method for iron smelting. Workers layered charcoal and iron ore inside a stone or clay furnace, then used bellows to force air through the chamber. This created a fire hot enough to separate the metal from the ore, producing a spongy mass called a bloom. This bloom still contained impurities and slag that needed further refinement through hammering and reheating. Copper and silver required different approaches. Their smelting used specialized furnace designs and added materials called fluxes, like limestone or silica, which helped separate pure metal from impurities by lowering melting points. The chemical reactions were complex. For iron smelting, carbon from the charcoal reacted with iron oxide in the ore, reducing it to metallic iron. Fluxes reacted with impurities to form slag, which could then be removed. Skilled workers judged temperature by watching the color and consistency of the materials inside the furnace. They managed fuel consumption carefully, since charcoal was expensive, and inefficient smelting could waste both ore and energy. Yields varied widely depending on ore quality and skill, often lower than modern processes, but impressive given their simple tools. What made this possible were sophisticated furnace designs and precise fuel management that could reach temperatures up to 1,500 degrees Celsius. The introduction of water-powered bellows and hammers later improved efficiency, but even early medieval smelters achieved remarkable results through experience and observation. This transformation from rock to metal was alchemy in the truest sense, part science, part art, and entirely essential to medieval life. Now, let's consider how blacksmiths transformed those rough metal bars into the precision items that medieval society needed. Blacksmiths received materials that still required extensive work. Iron blooms from the furnace were porous, irregular, and contained impurities that had to be removed through careful forging. Different items demanded completely different techniques. Swords required pattern welding, a sophisticated process where the smith layered and folded different types of steel together. This created a blade with both strength and flexibility, while the folding produced distinctive surface patterns. The final heat treatment was critical, heating and quenching the blade at precise temperatures to achieve the right balance between hardness and toughness. Armor presented another challenge entirely. Smiths had to shape and join complex curved plates that would protect the wearer while allowing movement. They hammered heated metal over forms called stakes, then carefully riveted pieces together. Each suit was essentially custom-made, requiring both metalworking skill and an understanding of human anatomy. For household items like nails and tools, blacksmiths developed mass production methods. They used specialized jigs and tools to quickly produce large quantities of identical items. This efficiency was crucial for meeting the demands of growing towns and construction projects. Coin minting required yet another set of skills. Smiths created precise dies with intricate designs and struck metal blanks to produce coins of standardized weight and appearance. This demanded consistency and attention to detail, as variations could undermine trust in the currency. The evidence shows blacksmiths relied on empirical observation rather than formal education. They learned through hands-on experience, constantly refining their techniques through trial and error. This practical approach drove innovation throughout the medieval period. How did iron ore eventually become a sword? Through multiple stages of forging, folding, and heat treatment, transforming brittle metal into flexible steel. The process required not just strength, but precise judgment of temperature and timing. Each hammer blow and each heating cycle gradually turned raw material into a finished product, ready for use in battle, construction, or daily life.